we are going to talk about a proper integral and improper integral. So first, what is mean by a proper integral, and next we will see what is mean by improper integral, or like we will compare those two things. First, let us take an example, integral over f of x dx a to b. So limits are given as, so lower limit is a and upper limit is b. Okay, so limits are a and b. Now, first condition to say that it is improper integral. So what is that first condition? If this, any of this, either a or b or both a and b, if any of this limit value or both a and b value or both the limits value or any of the one limit value, if this becomes infinity, if this become infinite, which means it can be minus infinite or it can be infinite. Let us take some example. Integral over 0 to infinity x square plus 2x dx. First example. Let us take another example, second example. Integral over sin x dx. Let us take it as minus infinity to infinity. Okay. So I have two examples here. In this two example, in the first example, a is becoming 0 and b become infinity. In the second example, a is minus infinity and b is infinity. In both the examples, any one of the limit value is becoming infinity, right? So if any one of the limit value becomes infinity, then I will call this integral as improper integral. This integral as improper integral. So what does integration means? Integration is nothing but if I take, if I draw it in the curve, and if this is f of x, if for the first example it is between 0 to infinity, but this infinite value cannot be defined, right? For the second example it is minus infinity to infinity. So this integration of sin x dx symbolized, or integration of any f of x dx telling you area below that particular curve, area below this particular curve. So if I define any limits between minus infinity or infinity, any one limit becomes infinite, then this area will also be infinite. I cannot find what is the proper area, right? So here this is called as improper area. So improper integral, or they will be calling it as improper area. So both are same. Like if I am doing an integration of any function, and if that value, if any one value of limits become infinity, or if any one of the limits become minus infinity, or if both becomes infinity or minus infinity, then the complete integral is called as improper integral, or it is called as improper area, because the area cannot be defined properly, right? So it is improper area or improper integral. This is the first condition for defining improper integral. So in the first case I said either a or b or a and b, this value should become infinite. If it is infinite, then I will be calling this integral as improper integral. So this is the first case. So what you need to do, if they are asking you to find whether the integral is proper integral or improper integral, first is you need to check the limits. If the limits become infinite, then directly write it as improper integral. If the limits are not infinite, both a and b are not infinite. For example, let us take 0 to some 4 or something like, let me take it like this, minus 1 to 1 by x square dx. Okay. Another example, 0 to pi by 2 tan x dx. So I am taking two examples in this case. Now in this case, minus 1 is a and 1 is b. 0 is a, pi by 2 is b. So in these two examples, both a and b values are not infinite, like they are not minus infinity, they are not plus infinity. Then what you need to do is, we cannot say that it is improper integral directly. Then you need to check the second condition. So what is that second condition? If f of x is what? This is f of x in this case. In this case, this is f of x, right? Anyone, like for the first case this is f of x, for the second case that is f of x. if f of x approaches to 0, sorry, if f of x approaches infinity. So what I need to check, between these two limits, minus 1 and 1, between these two limits, any one of the value, maybe minus 1, between 1 there are many values, 1, 0.9, 0.8, 0.4, 0, minus 0.9, 0.8, minus 0.7, all these values are between minus 1 to 1. Any one value between these two limits makes this f of x value infinity, then it will fall under improper integral. Let me explain this much properly. If you take this example, like for the first example, if I take the first example, then what is happening? When x is equal to this, these are x values, that is minus 1 to 1. When x is equal to 0, f of x is nothing but 1 by x square, right? So which will be what? F of 0, when x becomes 0, f of 0 will be infinity, and this 0 value is lying between minus 1 to 1. 0 value has to lie between minus 1 to 1, right? So f of x is approaching to infinity on 0, and this 0 value is lying between minus 1 to 1, that is this 0 value is lying between a and b. So this integral is also improper integral. I hope this is clear. Let us take that example of tan x. In case of tan, when x becomes pi by 2, everyone familiar about this, when x becomes pi by 2, that is when it becomes 90 degree, when x becomes pi by 2, f of x will be equal to tan x, which is equal to tan pi by 2. So what is the value of tan pi by 2? Tan 90. Tan 90 value is infinity, that is tan pi by 2 value is infinity. So f of x value is approaching to infinity between these two limits a and b. Remember one point, between these two limits means you can consider a and b also. If f of x becomes infinity at 0, or if f of x becomes infinity at b, then also it is considered. It should be from a until it reaches b, from 0 until it reaches pi by 2. It may become infinity at 0, or it may become infinity at pi by 2. Then if it becomes infinity, then it is said to be improper. So let me explain the two conditions very clearly. First thing, directly go to the question and check a and b. Directly go to the question and check a and b. If a is infinity or b is infinity, or both a and b are infinite, then directly answer it as improper integral. That's it, the integral will be improper. Second condition, if a value and b value both are not infinite, both are not minus infinity or both are not plus infinity, then go for the second condition. What you need to do, check f of x value, f of x term. Check f of x term with this a and b term, between a and b term. Between a and b, is there any value which makes f of x infinity? Any value between a and b, and which includes a and b also. In this case, minus 1 to 1, which include minus 1 and 1 also. Here in this case, between minus 1 to 1, if I substitute 0, f of x is becoming infinity. So between minus 1 to 1, which is making f of x infinity. If it makes infinity, then it is improper. If no values, if there is no value between minus 1 to 1, let us take an example. Integral over 0 to 10 x cube plus 2x dx. Now in this case, if I substitute 0, it will be 0. F of x will be 0. If I substitute 10, f of x will have some value. If I substitute 1, or if I substitute 2, or if I substitute 3, or any values between 0 and 10, f of x will be still will be having some finite value. It is not going to reach infinity. So this function is not improper. This integral is not improper. This is proper integral. Okay. But in the first case which I gave, at x is equal to 0, this 0 lying between minus 1 to 1, at this case it is becoming infinity, so it is improper integral. And in this case, between 0 to pi by 2, at pi by 2, tan x is becoming infinity, so this is improper integral. That's it. First step is to check whether the limits, second step is to take that limit between those two limits, check whether f of x is becoming infinity or not. If it becomes infinity, it is improper integral. If it doesn't becomes infinity, they are proper integral. In other words, it is like improper area and proper area. Like, let me give the idea for this. For example, if it is containing infinite and minus infinite in limit value, then we cannot define proper area under that curve, right? The area will be infinity, we cannot define. So it is improper area. Now in the same way, between some value f of x is becoming infinity, which means what? For example, I am taking a curve like this. This is f of x and this is f. Between a and b, between a and between b, I am defining a curve f of x, and between a and b at some point it is reaching infinity. At some point the curve is reaching infinity, right? The infinity means it is not going to be, we cannot define it. It is reaching infinity between a and b. So obviously now this area under f of x can also not be defined properly, because in between a and b there was one point where it is reaching infinity. Again I cannot define area properly, so it is again improper area. So improper integral and proper integral can also be called as proper area, and proper integral is proper area and improper integral is improper area.